Today we are going to do the antifreeze lab and determine the effect antifreeze has on the freezing and boiling point of water. Antifreeze, also known as ethylene glycol, has the formula of C2H6O2. This is the line structure of ethylene glycol, and this is the Lewis structure of ethylene glycol. It has two carbon atoms with two OH atoms attached to it. Ethylene glycol is used in cold weather to keep the car engines from freezing. Today's lab deals with colligative properties, which are properties that deal with the number of particles in the solution and not the identity. Examples of colligative properties are freezing point depression, osmotic pressure, boiling point elevation, and vapor pressure. Today's lab is going to deal with freezing point depression and boiling point elevation. Freezing point depression is the change in the freezing point when a solute is added, and boiling point elevation is the change in the boiling point when a solute is added. And their formulas are change in temperature is the number of particles times the constant times the concentration. Likewise, for boiling point, change in boiling point is equal to number of particles times the constant times the concentration. Today's lab, we're going to prove that adding ethylene glycol to water is going to change freezing point and boiling point. The first step is to pour 25 milliliters of water into each of the 300 milliliter beakers. We will be testing freezing point depression and boiling point elevation. The first beaker will have no antifreeze, the second beaker will have 3 milliliters of antifreeze, and the third beaker will have 6 milliliters of antifreeze. Measure this out using the 10 milliliter graduated cylinder and pour into beakers 2 and 3 accordingly. Now pour an inch of each antifreeze solution into each of the 3 test tubes, and then create an ice bath using the 6 ice cubes and the 20 grams of salt. This will be used to check the freezing point of each solution. You can stir the ice bath to mix up the ice and the salt to make it colder. Let each test tube sit inside the ice bath. When the solution starts freezing, check the temperature. That will be your freezing point. It requires boiling the solutions. Take the beakers with the rest of the solutions and place them on the hot plate and leave them to boil. When they do come to a boil, put in the thermometer and check what temperature they are at. Record these temperatures for comparison later on.
Alright, so in our final results, we collected the freezing and boiling points of 3 solutions. The first is just distilled water, and that froze at 0 degrees Celsius and boiled at 94 degrees Celsius. Next, we have an antifreeze solution with 3 milliliters of antifreeze, and that froze at a lower temperature at negative 2 degrees Celsius and boiled at a higher temperature at 98 degrees Celsius. And last, we have an antifreeze sample of higher concentration with 6 milliliters of antifreeze, and that froze at an even lower temperature and boiled at a higher temperature, negative 6 degrees Celsius for freezing and 99 degrees Celsius for boiling. So this is in accordance with the colligative properties we talked about with freezing point depression and boiling point elevation.
Today's bond, atom bond. Keep rolling to the end. And then disappear.